Steel built the modern world. From bridges, cars, skyscrapers, ships, all the way to the frame of the phone you are holding in your hand, this material is almost everywhere. For more than a century, the countries that produced the most steel were also the ones with the strongest voice in global manufacturing. And for most of that time, Western nations like the United States, Germany, and the United Kingdom were always near the top. But there is one number that should make you stop for a moment: 960.8 million metric tons. That is the amount of steel China produced in just 1 year, in 2025, from a single country. That number is bigger than more than half of all the steel produced by every other nation on the planet combined. To put it into perspective, the entire United States produced around 80 million metric tons of steel in that same year. China's output was more than 12 times higher. One Chinese company alone, China Baowu, produced more steel than all American steel mills combined. At this point, you might be thinking, all right, that is a huge amount of steel. But volume alone is not enough to win a technology race. The country that makes the most of something does not always make the best version of it. The real issue is that China is not just making more steel. They are making a completely different kind of steel. A kind of steel that most Western factories, quite literally, cannot produce right now. And the gap between what China can build and what the West can build is getting wider every single year. By the end of this video, you will understand exactly why that matters, not just for car companies or construction firms, but for the kind of world all of us are going to live in. Steel is not as simple as you probably think. Most of us imagine steel as one single thing, hard, shiny, and heavy. It is the material in a car bumper or the steel beam of a high-rise building. But in reality, steel is an entire family of materials, and the differences between members of that family are enormous. Think of it like bread. White sandwich bread and a freshly baked sourdough loaf are both technically bread, but one of them can take up to 3 days to make and requires a careful mix of natural yeast, controlled fermentation, and specific temperatures. From the outside, they may look somewhat similar, but they are actually completely different products made through completely different processes. Traditional steel is like white sandwich bread in the world of metals. It works fine for many uses, but what China has been quietly perfecting over the years is more like that sourdough loaf. More precisely, it is called advanced high-strength steel, especially the third generation of this material. Before that sounds too dry, here is what it means in plain language. Normal strong steel is tough, but it is not very flexible. If you try to bend it into a complicated shape, it can crack or break. That is a massive problem when manufacturers need to stamp curved car doors or complex structural parts. So for many years, manufacturers had to accept a trade-off. They could either use softer steel that was easier to shape but not very strong, or harder steel that was stronger but difficult to bend and process. Third-generation advanced high-strength steel removes that trade-off. It is steel that is extremely strong, yet can still be bent into complex shapes without cracking. Scientists engineer its internal structure at the microscopic level, controlling the tiny crystals and phases inside the metal to get both advantages at the same time. The result is sheet steel that can handle forces so extreme they were almost impossible to reach just about a decade ago, while still being stamped and shaped with normal factory equipment. That last part is extremely important. You do not need to build an entirely new factory just to use it. You simply need access to the material. And right now, China has that material in abundance, while most of the rest of the world does not. This is where the real-world impact starts to become clear for every car, bridge, and building. Volkswagen once switched to this new class of steel on one of its electric vehicle platforms and reduced the weight of the car body by 27%. Not the whole car, just the structural frame, the bones of the vehicle, 27% lighter. That directly turns into better driving range for electric vehicles, lower fuel consumption for gasoline cars, and a safer crash structure because the steel itself is much stronger. Hyundai and Kia also used a version of this steel in floor panels and reduced the weight by 30%. 30% from the floor alone. And the electric driving range of those vehicles improved in a measurable way. Now think about what this means at scale. Every car company in the world is trying to build vehicles that are lighter, safer, and cheaper, especially as electric vehicles are slowly taking over the market because every kilogram of weight saved means more distance on each charge. Advanced high-strength steel is one of the most cost-effective ways to do that. It is cheaper than carbon fiber, lighter than traditional steel, and it works on existing production equipment. So almost every automaker on the planet wants as much of this steel as possible. And this is where the math becomes uncomfortable for Western manufacturers. In 2025, Chinese advanced high-strength steel was leaving ports at prices around 15 to 20% lower than comparable steel from Europe or North America. This is not a small gap, and it is not a rounding error. It is a stable, structural price difference that buyers cannot ignore. A purchasing manager at a car factory in Germany or Ohio is not making an ideological decision when comparing two quotes. They are doing the math, and more of that math points toward China. But this story is not only about cars. Construction companies use high-strength steel in buildings and bridges to build lighter, taller, and with less material. Energy companies use it in wind turbines and pipelines. Defense contractors use it in vehicles and equipment where the strength-to-weight ratio is critical. Anywhere strength and weight are locked in the same difficult equation, this new class of steel has the advantage. And right now, China can produce it at industrial scale, while most Western steel mills still cannot. That gap is not just a commercial inconvenience. It is a structural shift in the question of who gets to become the backbone of modern industry. So why do Western steel companies not simply build new factories? Why not invest in the equipment, hire engineers, and catch up? The answer is a mix of economics, history, and one number that can make your jaw drop: $300 million. That is the minimum cost of building a new advanced high-strength steel production line. And that is not even a complete steel mill. It is just one line, one part of the process. To turn a traditional steel plant into a facility capable of producing third-generation grades at competitive scale, the upgrade cost can reach hundreds of millions, even billions of dollars, often with multi-year shutdowns of existing operations. And, after spending all that money, you come out on the other side having to compete against Chinese mills that already have years of head start and lower costs. On top of that, there is a historical problem. Most major steel mills in the United States and Europe were built decades ago. Some were designed in the 1970s and 1980s. They run on what are called blast furnaces, huge industrial structures that burn coal to melt iron ore. These plants were not designed for the fast and precise temperature cycles that new steel grades require. Retrofitting them is not like upgrading a computer. It is more like trying to turn a freight train into a sports car by swapping a few parts while the train is still moving. Financial analysts have looked closely at this problem and estimate that Western mills now face a cost disadvantage of around 35 to 45% per ton of advanced high-strength steel compared with Chinese producers. Not because Western workers are less skilled, and not because Western engineers are less intelligent, but because the capital structure of these old plants creates costs that cannot be competed away without rebuilding from the ground up. By 2025, companies like U.S. Steel, ArcelorMittal, and ThyssenKrupp had all publicly mentioned delays in their own high-strength steel expansion plans. In earnings calls and investor presentations, the theme was always the same: limited capital, uncertainty, and the brutal difficulty of justifying a $300 million investment when Chinese competitors can sell the finished product for up to 40% less. One executive, speaking without being named, said something that goes straight to the heart of the issue. The market was there. The technology was known, but no private investor wanted to be the first to put money into a $300 million production line when Chinese mills could undercut them before the line even opened. Private capital follows returns, and right now the returns from building advanced high-strength steel capacity in the West are extremely uncertain. This is not a problem the market can simply fix by itself. This is a problem governments have to step into, or it does not get solved. So what is China doing on the government side of this equation? That is where the story becomes truly massive. In September 2025, China's Ministry of Industry and Information Technology released a national work plan for the steel industry. This was a detailed multi-year roadmap designed to transform the way China makes steel, not just making more of it, but making it better, cleaner, and more strategically dominant. The financial scale behind this plan, through state investment channels, policy banks, and industry-directed funding, is estimated at around $18 billion through 2030. To understand why this matters, you need to understand what that money is being spent on. The largest portion, more than $8 billion, is going into hydrogen-based steelmaking. Traditional steel production burns coal, a lot of coal. Steel manufacturing is one of the largest sources of industrial carbon emissions on the planet. Hydrogen-based production replaces coal with hydrogen, and when hydrogen is used, it produces water instead of carbon dioxide. It is cleaner, and it also produces iron in a form that works especially well with electric arc furnaces used to make high-strength specialty steels. China is building large-scale hydrogen steel projects in 3 key provinces, with 2 of its biggest steel groups tasked with producing 1 million tons per year of direct reduced iron using green hydrogen. This is not a research project. This is industrial production at scale. Another $5 billion is going into rapidly expanding electric arc furnace capacity, with the goal of doubling China's electric arc furnace output to 150 million tons by 2030. Electric arc furnaces are more flexible than blast furnaces. They can switch between steel grades faster, handle the thermal cycles that advanced steels require, and run on electricity instead of coal. For producing third-generation, advanced high-strength steel, electric arc furnaces are significantly better tools. The remaining funding is being used for regional hydrogen clusters, research partnerships between universities and factories, and the training of the next generation of materials engineers and metallurgists. But underneath this entire infrastructure story is a strategic layer that makes it much bigger. The European Union is rolling out something called the Carbon Border Adjustment Mechanism. Starting in 2026, this mechanism places a carbon cost on imported goods, including steel, based on the emissions created during production. If you make steel by burning coal, you have to pay a tax to enter the European market. If you make steel with hydrogen or clean electricity, you pay very little, or possibly nothing at all. China's $18 billion plan is not just about making better steel. It is also about making sure that when those carbon tariffs begin to take effect, Chinese steel can still enter global markets with strong competitiveness, possibly almost tariff-free, while Western steel made with old blast furnaces faces its own carbon costs at home. China is playing the long game, and the board has already been set. Even if a Western company wanted to build a world-class advanced high-strength steel facility tomorrow, there is still a supply chain problem sitting underneath the technology problem that almost no one talks about. Making high-performance steel is not just about heating iron and adding carbon. Third-generation grades require extremely precise amounts of alloying elements. Metals like vanadium, manganese, and niobium are added to create the special microscopic structures that give the steel its superior properties. China controls a dominant share of global processing capacity for all 3 of these elements. That means even if a Western mill built a brand new, state-of-the-art advanced high-strength steel facility, it would very likely still need to buy key inputs from Chinese refiners in order to run it. This is not a coincidence, and it is not simply geographic luck. It is the result of decades of strategic investment in mining, processing, and refining. China identified which raw materials would matter most for the future of manufacturing and built supply chains around them before most of the world was even paying attention. There is also a knowledge gap that is just as important as the minerals gap. Steel patents are a window into who is really doing the cutting-edge thinking in this field. And over the past decade, China has rapidly increased its share of global patents in both advanced high-strength steel chemistry and hydrogen-based metallurgy. Chinese applicants now account for a significant share of new green steel patents filed globally each year. Patents are not just legal protection. They are also a map showing where a country's industrial knowledge sits. When you own a deep patent portfolio in a technology, you control the most efficient ways to produce it. Other manufacturers can try to work around those patents, but working around them means higher costs, longer timelines, and weaker results. In practice, this means the gap between China and the rest of the world in this specific area of manufacturing is not only about machines and money. It is also about knowledge, materials, and proprietary process know-how that has been accumulating for years, something that cannot simply be bought off the shelf. And China is not standing still. It is using third-country manufacturing hubs in Southeast Asia, the Middle East, and parts of Africa to bring production capacity closer to Western markets. Factories in these regions produce advanced high-strength steel, using Chinese technology, Chinese equipment, and often engineers trained by China. The finished material then enters European and North American markets from those locations, sometimes avoiding the direct tariff pressure aimed at goods coming from Chinese ports. The global market for advanced high-strength steel is projected to reach nearly $50 billion by 2034. The Asia-Pacific region is expected to capture most of that growth if the current trend continues. The supply chains feeding that market will run through technology, materials, and production facilities controlled by China. Whether the final product ships from Shanghai or Kuala Lumpur, what happens next still matters a lot to you. By 2030, if nothing changes, many major manufacturing sectors will face a reality where the most important input material for building modern vehicles, structures, and equipment flows through supply chains that are largely outside Western control. This is not a problem about pride or national identity. This is a practical problem with practical consequences. When automakers in Germany or Ohio buy advanced high-strength steel, the price they pay determines how competitive their cars are in global markets. If they have to pay 20% more than their rivals for the same material, they are already at a disadvantage before the first bolt is even tightened. They either pass that cost on to consumers, cut it from somewhere else, or accept lower margins. None of those choices are good. For defense manufacturers, the question of dependence is even more direct. Military vehicles, aircraft structures, and naval components increasingly require high-performance steel grades. If the supply chain for those materials runs through a single geography, that becomes a strategic vulnerability in a way that a cheap consumer goods supply chain simply does not. Western governments are beginning to recognize this. The United States has pushed to revive domestic steel investment through a combination of tariffs, subsidies, and requirements that defense procurement use domestically produced materials. The European Union's Carbon Border Adjustment Mechanism creates an indirect incentive to build cleaner domestic production. Some member states are also considering direct co-investment in steel capacity as a tool of industrial policy. But the scale of state support in the West is still only a fraction of what China has already deployed. And in this story, time matters a lot. Every year that passes without serious investment in next-generation Western steel capacity is another year for Chinese producers to expand their technical lead, deepen their patent portfolios, and strengthen their relationships with global buyers. The story of advanced high-strength steel is ultimately a story about what kind of industrial future we are going to build, and who gets to lead that future. China did not accidentally fall into this position. It chose it, invested in it, and executed on it for many years. That is a lesson in industrial strategy worth understanding, no matter where you are on the map. The rules of global manufacturing are not carved in stone. They are written through capital, research, and decisions made today about what the world will need tomorrow. Right now, one country is writing those rules faster than anyone else. The question is whether other countries can catch up, and that race has already begun. The material this race is being run on is no longer the steel your grandfather used to know. It is something new, engineered at scales the naked eye can barely see, and it will shape the next 100 years of how the world builds itself. If you found this useful, hit the like button and subscribe so you do not miss what is coming next. Turn on notifications, because over the next few weeks, we are going deep into the technologies reshaping global manufacturing. And here is the question for the comments. Do you think Western governments will invest enough to close this gap, or has China's head start become too large to overcome? Let us know what you think.